welcome to the fourth video of the XRPL4J video series. Today we will be analyzing a ledger. So today we can even use the mainnet because we won't be submitting a transaction. But as you know, if we have a quick look at the XRP scan, we can always see the current ledger. So right now we're at ledger whatever 99,443,428. And if we click on one of these ledgers, in this case I'm at 429, then we can see, for example, that this ledger included 112 transactions. We can even see the same view, but just a little bit more visual on the livenet.xrpl.org link. I'm also going to save that. This is more or less the same display, but this is more visualized and cooler to track here. So let's see, maybe it got blocked. Okay, it's working, yeah. So we can see now, right now, the same thing here going on. So there you can also somehow track the consensus. Like you can see at the bottom here, like the UNL validators and then all the other validators participating in the voting process here. And then we can see, as I mentioned, the ledger number, so or the height, 91,444,439. We can see that this ledger, for example, contains 60 transactions, and then there are displays for different transactions. Like this play button here is for payments. Then this blue circle is for creating offers, so meaning a DEX trade. This circle with a cross in the middle, so this whatever forbid sign, is canceling an existing offer that wasn't filled. Then we've got a green one here. Okay, you can see here it's grayed out a bit if the transaction fails. So for example, you can see here that somebody tried to do a payment, but tag path partial, probably meaning that there was not enough funding, for example, to send a transaction or to trade or something like that. Maybe you can see here what happened. So somebody was sending XRP in this case, and partial payment. We'll have to check again. There's also some exchanges used to there used to be a bug or something like that where exchanges didn't check for partial payment, or there's like a partial flag, I think, and exchanges like credited more than was actually sent or something like that. But not to go too deep into that, we will now look at again at IntelliJ. Again, we will now get rid of some of the code, or I'm gonna for now even put that aside here, so we can start again more or less from scratch. I'm just gonna put this into a comment here for now, to be used later again. So in this case, we don't really need much code, and also today we don't need to use. We can also create a variable here. We have a public static string, and this, for example, testnet URL, and then we're gonna copy that one here. And then we're going to create a new one, because for LiveNet, public, so again, public, almost static string, and then we're going to have a LiveNet URL, right? So meaning that we will now be connecting to the actual, to the live data, so to the production ledger, so like the real one in this case. And for that, we're going to quickly enter xrpl.org and enter public servers in a Google search. And then we can look again at the public servers that are currently available. We can use any of those here. For example, we've got here the xrpl.vs or whatever we want to use. We can also use, for example, the Ripple one. So let's just use, for example, the xrplclass.com, and and then paste it here. Okay, then in the get, we're gonna just say here LiveNet. Right, so now we got the XRP clients, and then obviously connecting to the actual LiveNet ledger, so XRP ledger network. Okay, then the next part. So this is going to be quite helpful, which we created last time. We can for now just comment it out. We're going to need it later, because right now the first thing we have to do is we have to query a ledger. So we'll say XRP client dot and then get, let's see, ledger info or ledger. Yep. So just using a ledger method, now we can create a ledger request params object again with the builder pattern .builder and .build. I'm just going to restructure it a bit so it looks nicer. And then in between those, in between the .builder and the .build, we can now set lots of different parameters. And let's go on. So the first thing we want to know, for example, we can specify a from full and so on, but we will need the ledger specifier. Then we're going to say ledger specifier dot current, for example. So we want to current ledger. that is right now is right now being processed. And let's see if there's anything else we want to say. There are lots of different things we can still queue, owner funds, full. So obviously we would have to check the docs for all of that, obviously. But for now, let's just keep it simple with just that. And then we will quickly check the return type of ledger. And the method ledger gives us a ledger result. So we're going to save that onto a ledger result. And I'm just seeing that I forgot to go into the presentation mode. That is my bad. So there we go. Okay, now it's easier to follow. Now let's go on here. And yeah, now let's save it. A ledger result is the data type. Ledger result equals down here. And then let's just simply print the ledger result, right? So everything else that was going on here can be ignored for now. Yeah, so right now main contains only these, whatever, however you want to count it, 3 statements, right? And then we've got one variable we need here, right? So this is simplified, nothing fancy, just a simple main class with a main method, and that's it. So hopefully easy enough to follow if you are doing it as well. Then let's now check the code, and we can see here right now we are now at ledger. We can see here a ledger of 99,443,521, and we can also compare that if this is true. So let's do it again. Let's click on play and then compare it with the live nets here. You can see here we've got 5 to 5, so this is that one here. This is the one that is currently processed, and yeah, so then we can also pass, I guess, transactions. So we have to tell it. So this is like very limited info, because right now we just queried like the current ledger, but we can also tell it, for example, yes, we want to see the transactions. Then we have to say transactions true because we want to see that. And now let's just start the program again. And maybe now we're also able to see, now we can see what is going on currently. Like now the output really increased by a lot, as you can see. Before there was literally nothing in it, but right now we can see all the transactions that are going on here. And yeah, now we're gonna access those, and then we can go check further. So I'm gonna for now delete the bottom part here. We don't need that. We're just gonna program it again. Ledger result dot, and then there's a ledger result dot ledger dot transactions. Yes, there we go. And we get a list of transaction results, and that's now what we're gonna handle. We get a list of transaction results, generic to question mark extending transaction. This, as always, list transaction result list. This looks more complicated than it is because the data types are quite nested. So you can see here we've just got a list, so an array or whatever, so list. Then generic to we've got a list of transaction results, and each transaction result contains one transaction, so one type of something that's a type transaction, because we know. So I don't know how familiar you are with generics, but for example, it might be a payment or an offer crate or so and so on, right? So obviously this needs to be generic because we don't know what it exactly is. We're quite certain, or we're absolutely certain, that it is inheriting from transaction, right? And yeah, this looks more complicated as mentioned as it is. Just copy that. Then for the next part, again, we're going to be using a loop. So let's just create a for loop. Right now this is helping, obviously. And then I'm going to remove that printing here because we don't need it anymore. We're going to be printing our own results. And then let's quickly see transaction result or transaction, and we're going to save that. For example, let's save that as transaction equals that, right? And then we can print out the transaction again. So there's not too much that's changing right now. So this will be more or less the same output again if we start it. But now we have it at least, now we're iterating over it. So if we now look at it, we can see here, well, there is a payment, offer crate, and so on. And one thing we can do, for example, we can do some counting. So that's obviously possible. So for example, let's say, well, let's create a map because we want, for example, so for those who are not familiar with maps, so let's say, for example, we want to see how many transactions have been pushed. Let's say, for example, it should say payment, for example, 10. It should say offer crate, for example, it should say well, offer crate. I don't know, offer crate, depending on how it's written, for example, 5 and so on. And for that we need a map because on the left side we've got the transaction type, and on the right side we've got the count. So let's create a map. That is on the left side, for example, storing a class, I guess. Let's try it with class. or we can also do it with string. Let's do it with string then, and an integer. And let's call it whatever, transaction tx count map, and equals new hash map, right? So this is, for those of you who are already familiar with maps, not too hard, hopefully. And then we're just gonna do one simple thing. We're gonna check if this transaction map contains a key. And in this case, we're gonna check if the transaction dot get. We can just have to see what we'll be using, obviously with the class. But maybe it's even, yeah, it's even the transaction type field is even better, because then now we're gonna change it to transaction type, because that's even better. And then we're just gonna be asking it if it contains a transaction type, transaction dot get transaction type. If it does, then we can just, yeah, then already is giving us this default code here. We're gonna again the same thing. Then we're gonna get the result, get the current value. For example, it's 4, so let's say, for example, it's payment, right? So we've got payment, then we're going to be asking, well, is payment already available? Yes, it has current value 4. Well, then we're going to, again, put it at payment. What do we put in there? We're going to get the current value of 4 and increment it by 1, and then it's 5. So this is like the common code, and then we have the else part, which is also already being suggested to us, because this is absolutely correct. We're gonna get the type and then set it to 1, because if there's no key, for example, let's say what else is there? We got the offer cancel. Let's say there's none, then obviously we're gonna put the offer cancel there and put the value 1 in there, and that's it. And after this loop is finished, then we can print out the map. Let's just do a simple print with the transaction map, and then we are just doing some counting, and we can see here on this. Then also we could obviously print out another statement saying ledger result dot ledger index, because that might be interesting. And then we can see that the ledger, never mind, then I should do it better, not ledger index, ledger, the ledger dot, now that's the way it has to be done, right? Ledger result to ledger index. And then we can see here, well, on the ledger, 99,443,614, there have been 77 offer creates, 67 payments, 1 trust set, and 10 offer cancels. So right now we're more or less just analyzing one specific ledger. And now we just did the same thing. So on the ledger, whatever, 618 here, there we've got 46 offer creates, 7 cancels, 38 token mints, and 60 payments. Yeah. Then thank you for watching, and see you in the next video.